Hey, grade 10s, in our last lesson, we took a look at balancing reactions. When you look at the chemical reactions, they had some stuff in common. They told us what was reacting. We knew the reactants. It was all of those things we had listed on the left-hand side, and we knew the products, the things that were produced that were listed on the right. But you might have noticed that there was patterns that you could have noticed. Sometimes there was only one reactant, sometimes two, sometimes one product, sometimes two. And the natures of those reactants and products were different too. Sometimes it was just an element that was reacting, and other times it was compounds. When we look at reactions, they actually fall into categories, and there's different ways we can lump them. One of the ways of classifying reactions is talking about whether or not they give off energy, usually in the form of heat and get hot. This is pretty common. Or whether they take in energy and end up feeling cold. When we look at whether something is going to give off or release energy, we're interested in if they're exo or endothermic. Exothermic, think of the word exo, sounds like extra, means that heat is being given off, it's being released. In an exothermic reaction, like when a match is burning, heat is produced. I could write the word heat as a product in the reaction. In the chemical reaction that we have here on our page, we have the chemical formula for propane gas reacting with oxygens to produce carbon dioxide, water, and heat energy. The reaction is exothermic. Some reactions are endothermic. They take heat in, and because they pull heat out of things like your hand, things feel cold when the energy leaves. Heat is required to make these reactions go. They don't go unless you heat them up. Quite often they feel cold because of it. Cold packs are one example of an endothermic reaction. Even when an ice cube melts, it requires heat going into it to melt the ice. It's endothermic. In any endothermic reaction, we would write the word heat as a reactant on the left. But a more common way to classify reactions is in terms of the nature of the products and reactants and the ways that the atoms rearrange themselves. We're going to start with synthesis reactions. Synthesis reactions are sometimes called addition reactions. They can also be called combination reactions. For the purpose of this video, we'll use the word synthesis, but really all are acceptable. In a synthesis reaction, we take two small things and stick them together. Take a look at the example that we have here where we have hydrogens. I've got two of them, and remember hydrogen's diatomic? So here's two groups of hydrogens, and I'm going to react them with diatomic oxygen. So I've got hydrogens and oxygens. They're little things, and when they react to produce combinations called water, and the water is hydrogen-oxygen combinations. So I have two little things reacting to form one big thing. The most common pattern is two elements react to make a compound. Here's some actual examples. I have calcium oxide and water. Here's one thing, here's another thing. But on the product side, there is only one thing produced, calcium hydroxides. Using the arrow as before and after, there's two things before and one thing after. This is a synthesis reaction. Same in the next example, we have iron and oxygen, and then after the reaction, you'll notice only one thing. Again, there are two things before the arrow and one thing after. This is how we recognize a synthesis reaction. Decomposition reactions are the exact opposite of synthesis reactions. In a decomposition reaction, we start off with one big thing, like a compound. In this case, I've got two groups of water molecules. But when water breaks apart, it breaks apart into its smaller bits. It breaks apart to form hydrogens and oxygens. When we take a look at this, what happens before and after the arrow, we have one thing before the arrow, and we have hydrogens and oxygens, two different things after. Here's another example. Before the arrow, we have calcium hydroxide. Then there's an arrow separating that a reaction's happened. And after the arrow, there's calcium oxide and water. There's one thing before and two things after. This is how we recognize a decomposition reaction. Another type of reaction is the single replacement reaction. In the single replacement reaction, you'll find that you have one small thing and a compound. Typically, you will see the formula of an element plus a compound reacts. Look at this example. Chlorine is an element. I recognize it as an element. It has a single name. Potassium bromide is a compound. So we have an element and a compound. What you notice happens is that the chlorine comes and kicks the bromine out. Bromine gets kicked out of this reaction to be by itself. And potassium is now hooked up with chlorine. It was like a couple was dancing and then they formed a new dance partner. That makes a single replacement reaction. One single thing was replaced. Look at this next example. We have aluminum reacting with iron oxide. Aluminum is a single thing. The balanced reaction shows that there is two of them, and I have this drawn below as two green aluminums. Iron oxide, specifically iron 3 oxide, because it is a transition metal, has 2 irons and 3 oxygens. I've got this written below, drawn in blue and yellow. What do you notice happens? I notice that the aluminum replaces the iron in the bonds with the oxygens. It's kicked the iron out. We now have iron by itself and aluminum in place of the oxygen. Because aluminum has replaced one single thing, it is a single replacement reaction. Any reaction that has an element plus a compound as our starting arrows will be a single replacement reaction. One more example would be this one. We have carbons, and you will see here in the reaction that we have 3 carbons. We'll color the carbons in yellow. I also have irons and oxygens. So here's my 3 carbons and my 2 groups of iron oxides. What do we notice happens? We notice that the irons get kicked out to be by themselves. And carbon has replaced the bonds with the oxygen. It's a new shape of bond, but that doesn't matter. We still have carbon hooking up with oxygen to be a carbon-oxygen bond. And the iron is now by itself. Carbon is an element. Iron oxide is a compound. Anytime you have an element plus a compound, you have a single replacement reaction. Another type of reaction that is a replacement reaction is the double replacement reaction. Double replacement reactions happen when you have 2 compounds and then an arrow. This is the general form for a double replacement reaction. I can see that the elements A and X have traded places. So A is now with Y and B is with X. Let's look at the example that we have below. You'll notice that we have iron 2 chloride. Think about the name, iron chloride. That makes it a compound. It's reacting with potassium sulfide, also a compound. These are both compounds because they both have more than one kind of element. Anytime we have a compound plus another compound, we have a double replacement reaction. You notice that the green chlorines are now attached to the blue potassiums, and the yellow iron is now attached to the red sulfur. We have had them trade partners. So this is the nature of a double replacement reaction. These are several other examples of double replacement reactions. Potassium iodide and lead nitrate. Again, it's a compound plus a compound. Zinc bromide and silver nitrate. Again, a compound plus a compound. Notice how the zinc is now attached to the nitrate and the silver is with the bromine. We have replaced in 2 spots. It is double replacement. One special type of double replacement reaction is called a neutralization reaction. In neutralization reactions, we have special compounds. An acid reacts with a base. The products are always the same. We get a salt and water. Now, when I say salt, I don't necessarily mean table salt. A salt to a chemist is just an ionic compound. Sodium hydroxide is a base. Hydrogen chloride is an acid. Here is water, and the sodium chloride is my salt. This is still a double displacement reaction, but it's a special kind of double displacement reaction that we'll talk about in a later unit on acids and bases. Our final reaction type is combustion reactions. To combust means to burn, and these are burning reactions. To burn usually means to combine with oxygen, and specifically for our goals, we will have carbon-hydrogen compounds combining with oxygen. We can burn other things, but ours will always have carbon and hydrogen. Any compound that has carbon, hydrogen, and oxygen only in the equation is going to be a combustion reaction. Here's two examples. CH4 is methane gas. When it combines with oxygen, it produces carbon dioxide and water. C6H12O6 is glucose. When it combines with oxygen, it produces carbon dioxide and water. Anything that has carbon in it and gets burned produces carbon dioxide and water. It's the same products every time. These are combustion reactions. Let's practice these few together. In the first example, we have iron plus oxygen makes iron oxide. I have two elements reacting to make a compound. You'll notice that there are two little things before the arrow reacting to make only one type of thing after. This is a synthesis reaction. In the next example, we have iron and then copper sulfate. Iron is a single name. The word copper sulfate has copper sulfate. It is a compound. Anytime we had an element plus a compound, we had a single replacement reaction. In question 3, we've got chromium. One name, it's an element. We've got tin chloride. Again, two names makes it a compound. As above, an element plus a compound is a single replacement reaction. In question 4, we have hydrogen dihydrogen dioxide. It is a compound. It has two parts, hydrogen and oxygen, but it's not reacting with anything. We have one thing by itself breaking apart to form two things. Anything you have only one thing and then an arrow, you've got a decomposition reaction. It's decomposing or breaking down. In example 5, we have calcium hydroxide. Again, we have calcium hydroxide, an element plus a compound. Two names, it's a compound. Hydrogen chloride. Again, two names, it's a compound. Anytime we had a compound plus another compound and then an arrow, we have a double replacement reaction. This kind of double replacement reaction specifically was a neutralization, but I don't expect you to memorize that at this point. It's enough to call it double replacement. In the final example, we have carbon. It's just an element. We have oxygen. It's just an element. This almost looks like combustion, but remember, combustion is carbon, hydrogen, and oxygen. And there's no hydrogens here. Combustion reactions also produce carbon dioxide and water. We're only producing carbon monoxide. This is a case of two elements makes a compound. Again, this example was a synthesis reaction. At the end of this package, we have more practice for you with equations. There's a space for you to classify each reaction, and then you may also practice balancing it. If you need more help in recognizing the different types of reactions, I will post other videos in the description found below the video.